Hi, my name is Niall Smith. I'm Head of Research at Cork Institute of Technology, and I'm also Head of Blackrock Castle Observatory. And tonight I'm going to be talking about how our view of the universe has changed from the early models, from the people of Newgrange, through to today. And I'm also going to explore how that has profoundly changed our view of ourselves, our place and our importance in this vast universe. I hope you get a chance to join me. Thank you very much for coming along tonight. My name is Niall. I'm just fascinated by the universe. I love the fact that we know stuff about our universe, and I think it's one of the great stories that we should share between each other. We do in Ireland very easily and well celebrate music and tradition and heritage and so on. We don't do a bad job with the science, but we could do better. But I think as a species, as people, our story is amazing, and that's a little bit what I want to get a little bit across tonight. And as Mary said, ideally in the classroom we don't want everybody sitting down, but tonight at some point you're going to have to go through maybe sort of a run through the whole bit before you can actually start to do spin-off activities which might be more interactive. At any stage, please feel free to ask questions, offer a separate opinion, whatever it might be, and we can do something at the end. I am unfortunately inclined to get into a rhythm, so don't let me stay on a set of train tracks if you're not happy with the direction that I'm going, if you have a counter view or a question. I'm not going to say anything vaguely offensive tonight, so I don't mean from that perspective, but you might have something where you have an anecdote you want to share with people, whatever it may be. So we talk about building models of the universe, because actually one of the things, and by the way, whether you're a teacher or not, hopefully you get something interesting. I've tried to craft it so that will be the case. But one of the things we're asked to do is to build models of the universe. How do we know what our universe looks like? So the way I want to look at it is first by looking at what we know about the universe today. And then I'm going to kind of go back and figure out how did we get here. And the reason why I want to do it this way is that there's maybe not complete unanimity of understanding in the audience amongst about what the universe looks like today. So I feel that if you put the model there and then you figure out how you get to it, at least you know where we're going on this particular journey. So today we believe the universe to be 13.7 billion years old, which means that it actually has a finite lifetime. Now, many of us may know this already, but just think of what we just said there. The universe has a finite lifetime. As far as we know, it wasn't always there. So at some point, 13.7 billion years ago, the universe came into existence. That's an enormous statement to make. We often gloss over it as if it's just the way things are. So we'll come to reasons later on as to why we think it's 13.7 billion years ago. The stuff we can see in the universe, a lot of us will be familiar with this. We have our Earth, we have our solar system, which is the sun and the planets, and then we have our galaxy. So we sit at the edge of a spiral galaxy, roughly here. It's called a spiral galaxy because it looks a bit like a spiral. And many of you may know that within this, there's about 100,000 million stars, each of which happens to be very similar. A bit of a variation, a bit like people, but roughly all the same, like our sun. So we have 100,000 million of these. Then we have a bunch of galaxies that are close together. They're called the local group. And then there's a bigger bunch which we call the local supercluster. You don't have to really, these two bits are not so important. I think they're interesting for various reasons. And then we have the universe, which is made up of all of those bits. But if we just run back through it, the main constituents of the universe are pretty straightforward. They're planets, they're stars, and then the stars and the planets come together to make galaxies. And then you just have more of those. So the universe is actually very repetitious in the way it's constructed. So 100 million stars, mostly like our sun, at least as many planets. There's lots of hydrogen gas, and I'll come back to that in a few minutes' time. We do a few exotic objects like black holes, but not so many of those. They don't dominate the universe. The universe is really, in terms of stuff we can see, dominated by stars, and there's roughly 100 billion galaxies, we think. So 100 billion galaxies, each with 100 billion stars. That's a lot of galaxies. So the first thing that we're saying today is two things. The universe has a finite age and it's got a lot of stuff in it. That makes the universe fascinating. It's also amazing that I can actually say that. Because when you think about the scale of the universe, I'm saying that as part of a species that's sitting on a very small planet in a very big universe, and yet I can make this claim. So this we know. If we look a little bit more closely at our solar system, this is a very quick run through, by the way. So you have the Sun, you have the inner planets, Mercury, Venus, Earth and Mars, and then you have the outer planets, Jupiter, Saturn, Uranus and Neptune. And of course we can have the debate over whether poor old Pluto out here remains a planet or not. I think a lot of the evidence really is debatable one way or the other, depends on how you define a planet exactly. And that's certainly something that in school you can start a discussion on it. But we also have visitors that come to us every so often, comets, and we have lumps of rock which are very small. This is not to scale. So these asteroids are only a couple of kilometers wide or long, and they float around the solar system. Every so often they bump into things. 65 million years ago, if you were a dinosaur, that was unfortunate for you. But 65 million years ago, when the dinosaurs got killed off, that allowed us as mammals to take over. We were actually being suppressed by the dinosaurs. And when the dinosaurs were knocked out, maybe a simplistic way of looking at it, it helped us. So maybe asteroids aren't all bad. But the universe, if we look at it in the greater context, is made of this normal matter. This is the stuff I've been talking about, the stars, the planets, in your typical pie chart, 4%, and the other 96%, roughly 95%, is made of two things, dark matter and dark energy. I'll explain to you in a few minutes kind of how we know about this a little bit. I'll explain what observations allow us. But I'll also draw attention to the comment, we've no idea what this is. Now to me that's really fascinating. We don't know what 95% of the universe really is made of. We can see only 5%, 4 or 5% in the stars and the planets. The other stuff, we don't know what it's made of. And that's true as we stand here today. So for the younger people in the audience, and if we're taking from a teaching point of view, this is something which we don't at the moment understand, and we got to get somebody somewhere to help us to figure it out. Why not our students? Why not our pupils? So this, we got to figure smart ways to look at the universe to figure out what most of it is made of. Why that's also important is this. It means there's a universe out there yet to be discovered. I mentioned a minute ago the universe is repetitious. Actually, it is, but there's bits of it, the majority of it, which we really don't understand, even if it looks repetitious. So that's kind of what we know about the universe today. Stars, galaxies, planets, dark energy, dark matter, it's expanding, it's 13.7 billion years old. That's roughly what the universe is. So how did we come to this realization? And the reason why this for us is interesting in part is because this is an example of a scientific discovery story. So if you're in this mound, and many of us will recognize it, have any of you been to Newgrange? Yeah, brilliant place, and if you haven't, really go there. But roughly 5,000 years ago, Newgrange was built aligning with the midwinter sun as it rises, a few days either side as well. And that we know about the mound. Actually, we know very little else because there's no written records. What we do know, because we can imagine this, if you lived 5,000 years ago, then any model that these people would have had about the universe, in other words, what they thought the universe was made of, where they thought it came from, how old they thought it was, they would have based that on just a few simple facts, because they didn't have telescopes, for example. So they would have seen that stars twinkle, they would have used their eyes only, they would have seen that there were these points of light that move. We call those planets today, but to them, I don't know what they were, we don't know what they thought they were, but they would have seen that. And they would have also seen every so often shooting stars or comets. So to a naked eye observer, you'll see roughly this, twinkling stars, maybe a few different colors in the stars. You see them, points that move in the sky, and then you also see things that come every so often. That's really pretty much as you can observe. So how do you build a model around that information? Well, people tried.